everybody, it's Ms. Phoebus, and this is Lesson 37, Simplifying Radicals and Solving Quadratics by Taking Square Roots. Alright, so our learning goals for today, I can write square roots in simplest radical form, and I can identify the zeros of a quadratic by inspection or by taking square roots. The standards, we should be able to explain the steps in solving a quadratic by taking square roots. And then we should be able to solve equations by taking square roots and recognize when a quadratic gives us a complex or a solution where we write no real solution. So we're on page 164 in the notes if you're following along. And so on page 164, I want you to find a calculator and work with the square root of 8, the square root of 2 times 4, and 2 square roots of 2. And I want you to change those into decimals. And then what do you notice about your answer? So pause the video and work on that right now. All right, so the square root of 8 is 2.828427125, etc. It's irrational. The square root of 2 times 4 is 2.828, so on. And 2 square roots of 2 is 2.828, and so on. And what did you notice? That all the decimals are the same, that all of them have a square root in them, but yet all of them are written a little bit differently. Notice here, we've got an 8 under the square root, and you should know that 2 times 4 is 8, so that is also under the square root. This is a little bit different, and really our end goal is to take something that looks like this and make it look like that. That is going to be simplifying our radicals, and the goal is to be able to take the square root of pieces of the numbers underneath. So if you look here, I can take the square root of 4, the square root of 4 is 2, but I can't take the square root of 2. It is not a nice number, so I leave it as the square root of 2. The square root of 2 is irrational, and so then I have the simplest radical form where I only have to write 3 things. 2 square root 2. I don't have to write that whole entire decimal that never ends, but I've already taken square root of part of the number. And so that's the whole simplifying process. So I have some steps for us to write down. But before we do that, we're going to look at the anatomy of a radical. So in the square root piece, that's called the radical, or you can call it the square root symbol. The number in front is still the coefficient, just like the coefficient on a variable, the number in front of the variable. And then the number underneath is the radicand. So the number underneath that radical, radicand. All right, so here are the steps. You're going to factor the radicand until you have only prime numbers. And then I do have a little change. When we get to some examples, I do want to talk to you about that. But you're going to factor the number underneath the radical. Which numbers can pair up? If there are a pair of numbers that are the same, you're going to circle them. Pull just one of those numbers outside the radical and eliminate the other. This number that you're pulling outside the radical becomes a coefficient. If you pull out more than one number at a time, you're going to multiply the coefficients together. Any remaining factors that did not get paired up stay underneath the radical. If there's more than one, we're going to multiply those numbers together. So we should have one coefficient out in front, one number as the radicand. All right, there's a whole list on this page of squaring numbers and their square roots, but up at the top there is a shape to fill in. It says u dot dot dot. I want you to write, you cannot take the square root of a negative number. You can't do it. Like what's your favorite number? Go to the calculator, type in the square root of negative your favorite number. Negative, square root of negative 47. Square root of negative 1,000,000. What do you get? In most calculators, you're going to get an error, and that error, especially like in the graphing calculator, if you read the error, what the error is spitting out, it says non-real solution. So the guy that invented the imaginary numbers, he wanted to take the square root of a negative number. So he had to develop a whole entire number system so that he could take the square root of that number. So you right now can't take the square root of the number. So if you are like, square root of a negative number is something I need to do, and you find yourself in that boat, we're going to say there's no real solution. So what we're going to do is we're going to start breaking down 20. And we want to break it down into numbers that are helpful, into factors that are helpful. So if I break down 20 as 1 times 20, that doesn't do anything for me. So I want to play around with numbers that multiply to give me 20 that I can break down, and I can start seeing some prime numbers. So 20 is 2 times 10. 2 is prime, 10 is not. And of course, when I say prime, prime means that it's only divisible by 1 in itself. So I've broken down 2. Now I'm going to break down 10. 10 is 2 times 5. Now sometimes, and this is kind of a personal thing, sometimes we see a whole bunch of numbers. We can get rid of the pieces that we've broken down. I broke down 20, I don't need it anymore. 20 is 2 times 10. I broke down 10, I don't need it anymore. So if I do 2 times 2 times 5, I get 20. So I want to break down those numbers so that I'm dealing with just the numbers that multiply to give me 20. So sometimes marking it out is a little confusing, but if that's what you need, I recommend doing it. All right, so we need a pair of numbers that match. And so if you see here, we've got 2 and 2. 2 and 2 are the same number. And what we do with a pair of numbers that match is it goes right out in front of the radical and becomes the coefficient. Now let's talk about why. Tell me about 2 times 2. 2 times 2 is 4. What's the square root of 4? 2. So it's like you took one of those numbers and put it outside. The other one doesn't matter anymore. So my final answer is 2 square roots of, and do you see this 5? That 5 does not have, there's not another 5 anywhere in that problem. It's the only number left. I can't take the square root of 5. The square root of 5 is an irrational number. So I leave it underneath so I don't have to mess around with that decimal. Now let's say for a moment that you did not say 2 times 10 is 20. So let's say for a moment you're like, you know what? 20 is 4 times 5. You're going to still be able to get the right answer. Because 5 is prime, I can't break it down anymore. If I look at 4, 4 is 2 times 2. I have a pair of 2's. They get to go outside the radical, be the coefficient. 5 is still there. It stays under the radical. So I have 2 radical 5. So I can still get the answer even if I break it down in different ways. Now, the problem is going to be where you're like, ooh, 20 is 10 times 10. 20 is not 10 times 10. 20 is 10 plus 10. This is all about multiplication. So I need to make sure I'm breaking these down into factors and not looking at things that add to give me that value. So here is our final answer, 2 square roots of 5. Now, one of the things that you also can do to make sure that you're on the right track is what we can do is we can type 2 square roots of 5 in the calculator, and we can look at the decimal 4.47 blah, 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 and then the square root of 20, and type that in the calculator and get 4.47 blah, blah, blah. Okay, but you have to be careful, and we'll look at a later example, because there are times when you can partially simplify, you don't simplify all the way, and you can still get that same decimal answer. But this is a way where if you want to be pretty sure that you simplified right, you can compare the decimals on those answers. All right, let's look at number 2. So what are 2 numbers that multiply to give you 128? Well, 128 is even, so that means it's divisible by 2. 2 goes into 128 64 times. So 2 is prime. I'm not going to do anything else with that because breaking it down to 2 times 1 isn't going to help. But let's break down 64 to 8 times 8. Now, this is where when in that very first step I said break it down, factor it into all the prime factors. There is a little bit of a earlier stopping point that you can use. If you can find a pair of numbers right away, you can use that. So 8 and 8 match. I could pull that out in front. And then 2 is the only one that doesn't have a partner. So 8 square roots of 2. But let's say for a moment you were like, nope, I'm going to go all the way to the end. I'm going to factor all of this to where I just have prime numbers. So we know 8 times 8 is 64. We know 8 is 4 times 2, and 4 is 2 times 2. So I broke it down. They're all prime. Now again, it might be helpful if you're like, okay, I'm breaking these down, and I'm getting rid of those bigger numbers. So again, that's a personal preference. So 8 is 2 times 4. 4 is 2 times 2. So get rid of this 8, get rid of this 4. So I've got just a mess of 2's. Okay, I recommend circling them so you know what you're dealing with. So I've got a pair here, a second pair here, a third pair here. Still, this guy's hanging out by himself. So let's pull out 1, 2, 3 2's. Now, when we pull out all 3 of those, they get multiplied. 2 times 2 times 2. What's 2 times 2 times 2? 8. And then this 2 right here is this 2 right there. So, because I sometimes can stop early, I might save myself a little bit of work. So something to watch for. Can you stop early? Do you have to go all the way to the prime factors? Okay, that's a question for yourself. What do you want to do? But the more numbers you have, the more a little confusing it can kind of be. All right, let's look at number 3. Number 3 is going to be 7 times 21. Now, how did I know it was 7 times 21? Well, I say a 14 and a 7, and both of those are divisible by 7. So divide into 7, and you can get 21. 21 is 7 times 3. So I have a pair of 7's, and I have a 3 that's left behind. So I'm going to give you a second. I want you to write the final answer. Remember, one number is going to be in front of the radical. The other one's going to be the radicand underneath the radical. All right, so we're going to pull the 7's out in front because that's where the pair is. The 3 is going to stay underneath. So sometimes I tell the story, or it kind of sounds like a story. The numbers that have a partner that match, that look just like them, they get to go outside the radical and play. The number that doesn't have a partner has to stay inside until maybe later on we multiply by something and we get a partner. But until then, they get to stay inside. So 7's on the outside, it's a coefficient. And then square roots of 3. 3 is the radicand, it stays under the radical. Now we can check that if you really want to, but it should have the same decimal value. If it doesn't have the same decimal value, that means you went wrong somewhere in your factoring. All right, so 4, 5, and 6. What I want you to do is I want you to play around with these. I want you to see how you're going to break them up, and if you choose a different way than me, that's okay. We should still arrive at the same answer. If you want to double check before watching me work it out, you can type the beginning problem in the calculator, look at its decimal, and type your answer in the calculator and compare those decimals to see if you're on the right track. Pause the video now. All right, 48. I would break this down into 4 times 12. Remember that. That might not have been the way that you do it. You chose to do it. Before I break down 4, I know 12 has a 4 in it. So I'm going to go ahead and do 12 as 4 times 3 so that I can see a pair of 4's that go outside the radical. The 3 stays underneath. And I really highlight or recommend doing the circling thing and then the underlining thing, what stays and the circle goes. It kind of helps out. 4 square roots of 3 is your answer. All right, let's look at number 5. Well, 27 is 3 times 9. 9 is 3 times 3. I have a pair of 3's. right, one of them becomes a coefficient. This 3 does not have a partner. It stays underneath, so 3 square roots of 3. All right, let's look at number 6. All right, 108 is even, so it's 2 times 54. 54 is even, it's 2 times 27. Now, I'm going to stop right here for just a second because I want to go into the whole, you can partially simplify something and not be fully correct. So let's say we stop right here. We pull out a pair of 2's. And then we write our answer as 2 square roots of 27, because there's just 27 right there. If we look at the decimal, the square root of 108 is 10.39 blah, blah, blah. And then if I type 2 square roots of 27 in my calculator, I get 10.39 blah, blah, blah. So you might be like, hey, guess what? I've finished. I completely simplified my radical. However, remember this problem that we just did? We were able to simplify that. And look what I have right here. I still have more work to do. So be very, very careful before you wrap up the problem and you say, there's nothing else I can do. There's more we can do. We can break down 27 into 3 times 9, and 9 into 3 times 3, and we have a pair of 3's that also get to go outside. Remember, when you have 2 numbers outside, you multiply them, and then this 3 stays underneath. So 2 times 3 from up here is 6 square roots of 3. And when you type that in the calculator, you also get 10.39. So blah, 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 by the way. But you can't stop too early. You want to stop when this number is either prime, can't be broken down into pairs, something like that. Okay? So you want to stop when this number has nothing else that has a perfect square in it that you could take the square root of. So that's a caution. All right, let's look at number 7. Now, some of you may be like, ooh, there's a negative. Yes, but is the negative under the square root? No, it is not. So the coefficient is just going to kind of hang out there until I bring something outside. So we're going to still focus on this 175 under the square root. 175 divided by 5 is 35. 35 we know is 5 and 7. I have a pair of 5's. Now what's going to happen is they're going to go outside and multiply times the negative 5 that's already there. The 7 is going to stay under the radical. So negative 5 times 5 is negative 25. And then square roots of 7. Now, one other thing that I want to kind of show you that is something that happens is people get excited and they go 7 staying, and they pull it out, and then they may even do something like this, but then they put the number that should be out in front underneath the radical. Checking the decimal is going to let you know that this is not the answer. Okay, so just keep that in mind, that where you place the numbers matters. You can't just willy-nilly flip-flop them unless it's like that 3 square roots of 3, and then yeah, it doesn't matter there. So be very careful. The numbers that are on the outside are the ones that are paired up. The number that is inside is the one that doesn't have a pair. All right, do you want to try number 8 and 9? Pause the video, see what you can do. All right, let's look at number 8. 63 is 9 times 7. 9 is 3 times 3. 7 is prime. Nothing's happening there. So we're going to pull out a 3 and multiply it times the 2 that was originally the coefficient. So 3 times 2 is 6. Square roots of, who stays behind? 7. 6 square roots of 7. All right, let's look at number 9. So we're going to break down 54. 54 is 9 times 6. 9 is 3 times 3. Now 6 is 3 times 2. You may feel the need to do that, but remember we're looking for pairs of the same number. So we're only going to be able to take out a 3. If you do this and you break down this 3 times 2, you have one of two options. You can say, well, I don't need that. I can go back up here. Or you could just multiply these pieces. I don't want to circle it, but you could multiply these pieces together, and that's what goes underneath the radical. So if you have two numbers that are still being multiplied, but they need to go together in the radicand, you can multiply them together. So up here I have negative 4 times 3, that's negative 12. Square roots of, and this is going to be a 6 underneath because 3 times 2 is 6. All right, now I'm going to go ahead and warn you. The next slide makes people cringe. That's because there's some fractions. Take a deep breath. You're going to be okay. I'm going to walk you through it. You're also going to be introduced to a new symbol. And the new symbol is something that we're going to be using in the next part of the lesson. Okay, so this symbol right here that's hanging out, this is called a plus or minus. Okay, and what that means is we're dealing with two answers. One's positive, one's negative. They're both the same number. So if I was looking at plus or minus 2, that means I'm looking at a positive 2 and a negative 2 at the same time. But instead of writing 2 twice, I only have to write the 2 one time. So it's a little bit of a shortcut when you write these things. Okay, so that's called a plus or minus. That's how you read it. And we have the square root of a fraction. Now, fractions are bad enough. Now we're throwing them under square roots, but it's going to be okay. I promise. I promise. So here's something that you are allowed to do. You've got the square root of a fraction. You are allowed to break this up into the square root of the top over the square root of the bottom. See, that's not too bad because I know you guys know the square root of 16 is 4, and I know you know the square root of 9 is 3. Didn't that make it easy? And then because we have that plus or minus, I want you to just go ahead and start practicing putting that plus or minus. It's going to come in handy in just a little bit. So what that represents is I have a positive 4/3 and a negative 4/3. It's two answers, two answers in one. All right, so do you want to try number 11? See what you can do. Pause the video. All right, so what we're going to do is we're going to do the square root of the top over the square root of the bottom. But if I can simplify a square root, I should. So the square root of 4 is 2 on top. The square root of 25 is 5 on the bottom. So a plus or minus in front of it, you're done. Now, is this something you can put in the calculator? Absolutely. Absolutely. And you can check it. Now, with the plus or minus, you might not be able to get that in the calculator because there's not really a symbol for that. But the square root of 4 over 25, that you can put in the calculator. And you would get a decimal, but you could change it to a fraction. All right. What do you think about number 12? You think you can handle number 12? See what you can do. Pause the video. All right, we're going to do the square root of 121 over the square root of 49. The square root of 121 is 11. The square root of 49 is 7. Throw a plus or minus in front of it. You're done. Let's look at 13. Square root of 27 over the square root of 100. Now, one of these is a perfect square. So far, in the last 3 examples, we've had perfect squares, but only one of these, the square root of 100, is a perfect square. So what are we going to do with that top? Well, remember what we were doing at the beginning? 27 is 3 times 9. 9 is 3 times 3. I've got a pair of 3s that get to go out in front. This 3 stays behind. So 3 square roots of 3 with a plus or minus in front of it. Now, you can simplify the pieces outside. The square root protects this 3. So the only way that you can change this piece is doing this whole process that we're doing here. That's the only way you can get in and change the number under the radical. But the numbers that aren't, the coefficients and that 10 on the bottom, those pieces you can treat like a normal fraction. Does 3/10 reduce? It doesn't. So there's nothing else you can do with this fraction. It's completely simplified. Now, there is something where the denominator, if you have a square root that doesn't break down, let's say I had like 1 divided by the square root of 3. There is something called rationalizing the denominator, which says get the square root out, okay? But we don't have to worry about that in Algebra 1. All of our stuff in Algebra 1 should come up with nice numbers in the denominator, nice whole numbers. So if you come across, like in a different video search or anything like that, needing to rationalize a denominator, that is Algebra 2 material. You don't have to worry about that right now. Okay, all of our numbers should be nice, like this square root of 49 should end up being nice in the denominator, turning into a 7. Okay, no square roots left there. Okay, so you want to try 14? See what you can do. All right, so 14 is the square root of 104 divided by the square root of 225. The square root of 104 is not a perfect square. 100 is a perfect square, 104 is not a perfect square. So we're going to deal with that in a second. But the square root of 225, you can flip back to that perfect square page. It's 15. I'm going to go ahead and put my plus or minus in front. Let's look at 104. It's an even number. It's divisible by 2. 2 and 52. 52 is even. 2 and 26. 26 is 2 and 13. I have a pair of 2's, but that's all I've got. So I'm going to leave that 26. So this is going to be pull out the 2. 2 square roots of 26. Quick check, can I divide 2 over 15? Can I simplify that fraction? No, it's already simplified, so there's nothing else I can do. Let's look at number 15. All right, so we're going to do the square root of 242 divided by the square root of 81. The square root of 81 is 9, so there are plus or minus in front of it. And then let's see, 242 is 2 and 121. Ooh, and 121 is 11 and 11. So I'm going to pull out a pair of 11s out in front, and then this 2 is going to stay underneath. So this is going to be 11 square roots of 2 on top. 11 over 9 doesn't reduce as a fraction, so that's all I can do. All right, so by the way, I wanted to let you know math is radical. It's pimples, 0. Blackheads, 0. The square root of 0, 0. Gotta love all these math means. My math teacher asked me why my shirt said the square root of the answer. You see it? Here's the square root. And ANS usually stands for answer. It does on your calculator. So the square root of the answer, not Vans. Who knew Vans were so mathematical? You must be the square root of 2 because I feel irrational without you. I finally found the square root. Look at all these math means. All right, we're going to flip to page 168. All right, on there, you should see a giant plus or minus. In order to do this method, you have to solve an equation that is written as ax squared equals c. So you have no x anywhere involved in the problem. So if you have an x, you can't do it this way. This is just, you've got an x squared. So remember when I wanted you to solve like 5x equals 10. Something very easy, and you had those properties of equality that you were using to solve for the variable. Now I'm going to ask you to solve for x squared. Okay, so it's the same kind of thing. We're going to isolate our variable, but we are going to then take the square root to get rid of that x squared, and then make sure we have that variable all by itself. We have to simplify our radicals. So let's go through some examples. So on number 1, my goal, pretend for just a moment, I'm solving for x. What would you do? What would you do first? When you add 180 and then divide by 5, you're going to do the same thing. You're going to move the pieces away from the x squared. So I'm going to add 180. So I'm going to have 5x squared equals 180. I'm going to divide by 5. So x squared equals, that's going to be 36. And then now, how do I get rid of a square? I've got to do the inverse operation. The inverse of squaring something is taking the square root. Remember that whole page that had squareds and square roots? So the inverse is taking the square root of both sides. Now when I do that, the squared and the square root cancel each other out, leaving behind x. Tell me about the square root of 36. You would say 6, but I argue there's another number. There is another number that when I square it and work backwards, I can get 36. 6 is one of them, but -6 is also an answer. So I have to come up with two answers. You see that squared? That means that there's two answers. And if I ignore one of them, then I'm going to be half wrong. I don't want to be half wrong. I want to be all right. So when I do this, this is where that plus or minus comes in. I want to put a plus or minus in front of my answer. Now, when does that happen? It happens after the square root. Once I take that square root, then what I get is my final thing that I'm writing down needs a plus or minus in front of it. So I get both of those answers. So that's going to be something that I keep harping on you about. And you're going to even hear, like if I'm teaching you in class, I'm going to be like, okay, well, guys, what's the square root of 49? And somebody says 7, and I'm going to say wrong. The square root of 49 is not 7. For you, it's plus or minus 7. So when you are solving for x, and you are trying to figure out all the answers, you have to have the plus or minus. Have to. Let's look at number 2. I'm going to add 15. That's my first step in getting x by itself. I have to divide by 3. If you start taking square roots way too early, it's not going to work. 15 divided by 3 is 5. Now I have my x squared by itself. Now I take the square root to get the squared to go away. The squared and the square root cancel, leaving behind x equals, can I take the square root of 5? Think back to what we did earlier. It doesn't break down as prime, right? So I'm going to have the square root of 5, but in front, make sure you have your plus and minus. So that is a big thing. And what I usually do is I pass out highlighters to everybody. Like every single time we do this, you're going to highlight your plus or minus. So if you've got a highlighter, come through and highlight this plus or minus. Make it stand out, because when you go back and you look at your notes, that is something that you're probably going to overlook. You don't want to overlook it. You don't want to get just one of the answers. You want to get both of the answers. All right, let's look at another one. Let's look at number 3. So we're going to first move that 32. We're going to subtract 32. So I've got -2x squared equals -32. Now here, a lot of times people get confused or excited or something, and they're like, I'm going to take the square root now. But if I take the square root now, I've got the square root of a negative number. That's not going to work, right? Because you can't take the square root of a negative number. You've got imaginary solutions. But I'm going to say, did you really isolate the x first? Because here, I need to divide by -2 so that I get x squared equals 16, which is positive, which is something I can take the square root of. Now let's take the square root. All right, x equals, now I want you sitting at home, you ready? You're going to tell me what the square root of 16 is. I know you think I'm crazy. I know you think you know the answer too, and we're going to watch and see. All right, what is the square root of 16? Say it out loud. Did you say plus or minus 4, or did you just say 4? If you just said 4, you just missed a whole answer. You missed the -4. So please get in your mind that this piece holds 2 answers, and if you want to get credit for both answers, you need that plus or minus. Okay? So I know you're not getting the full Miss Phoebus experience, but that's going to be what I'm going to say in class. I'm going to be like, hey guys, what's the square root of 16? And somebody's going to yell out 4, and I'm going to say, no, wrong. It's plus or minus 4. And I'll do it enough, hopefully, that people will understand. Unfortunately, you're getting this version of me. So sorry about that. All right, let's work on number 4. Actually, why don't you work on number 4? Pause the video. All right, let's subtract 6. We got 3x squared equals 27. We're going to divide by 3. X squared equals 9. And then we're going to take the square root of both sides. That's how you get rid of a square. Take the square root. All right, x equals plus or minus 3. Did you remember your plus or minus? I hope so. All right, let's look at number 5. So we're going to subtract 2 on both sides. 2x squared equals negative 2. We're going to divide by 2. X squared equals negative 1. And then we're going to take the square root of both sides. Uh-oh. Do you see that square root with a negative number underneath? That's not going to work. Not for us. Not right now. So we're going to write no real solution. But only if that x squared is by itself, and I'm taking the square root, and then on the other side I see that negative underneath. But it might be, something beneficial to go back and check. I subtracted, which is the opposite, adding 2. That looks good. Yeah, this is negative 2. Dividing by a positive 2. Yes, that's negative 1. So there's nothing that I can plug in to have that get an answer. That would work, right? All right, let's look at number 6. Now, number 6 is different. Compare number 6 to what we've been doing, number 5 and 4 and 3. Do you see what's different? You see those parentheses being squared? There's 2 things being squared. So we're going to handle that, but it's going to be after the square root. So after the square root, there's going to be an extra step. So we still want to get the pieces being squared. We want to get those parentheses by themselves before we take the square root. So I'm going to add 9 first. So I'm going to have x plus 2 squared equals 9. Now, how do I get this? Some people, they go off the rails. They're like, hey, we're going to multiply 2 of these, and then you're headed towards factoring territory, which is not going to be pleasant. I'll just go ahead and tell you that. It's a lot more work. For some reason, people are like, I'm going to do it this way, and it's like 18 steps longer than it needed to be. How do you get rid of a square? You take a square root of both sides. So the squared and the square root cancel. You're going to have x plus 2 equals, tell me about the square root of 9. Say it out loud. What's the square root of 9? Did you say plus or minus 3? If you didn't, you need to check yourself, because plus or minus has to be in front of that 3. Now what's about to happen is I still have to isolate that x. I'm going to subtract 2 on both sides. Now, there's a couple of things going on. You have to remember that this plus or minus belongs to this 3. I usually write it second. I usually write this piece first, and then the plus or minus goes in between these 2. Okay, that's usually what happens. What then you have to do, you can't leave this. Or can you add negative 2 and 3? Can you subtract negative 2 and 3? So if you can put those together, you have to. So this is really 2 problems. The first problem being what's negative 2 plus 3, we're going to get an answer. And the other problem being what's negative 2 minus 3, and we'll get an answer. So we're going to get 2 answers. In the past, this plus or minus 6 or whatever that we were getting, we could just write that one time. But in this case, because I can add and subtract, I have to make sure I do that. So negative 2 plus 3 is 1, and negative 2 minus 3 is negative 5. And I have 2 answers, 1 and negative 5. Just like, remember our zeros where we had 2 places where we were crossing the x-axis? These are the zeros, by the way. These are the x-intercepts. That's what we're finding. We're finding these solutions. And if you graphed all of this in the graphing calculator, it would cross the x-axis at 1 and negative 5. Guarantee it. Okay? So this is a different way to do things, where you don't have, an x squared and an x floating around. You just have one variable that you can solve for, and it's almost like a little bit of a shortcut, but you can't use it every single quadratic. All right, so number 7, what we'll have to do first is we'll have to get rid of that 3. Do you see? Remember, we're getting those parentheses by themselves. We've got a 3 out in front. How do you, we can't, don't you distribute that 3. Remember, like distributing into absolute value bars, don't you do it. Don't you do this, because that squared is taken care of. It's got a hold on that whole entire set of parentheses. It will not let that 3 go in, and if you try to distribute it and then do things to it, it's not going to work. So what we need to do is we need to divide by 3 here and here. 3 divided by 3 is 1. And then I've got this x minus 5 squared equals 18 divided by 3 is 6. Now we can take the square root of both sides. I end up with the squared and the square root canceling, so x minus 5 equals, and then I can't do a whole lot with 6, so I'm going to just write it as plus or minus the square root of 6. I'm not done yet. I'm very close to being done. X is almost by itself. I'm going to add 5 to both sides. And you're going to see x equals 5 plus or minus the square root of 6 as your answer. Now, you cannot add these. This is irrational. Irrational means that it is a decimal that does not go on and on, or irrational means that it is a decimal that goes on and on and on forever. Okay, you can't add it to a whole number or an integer. You could multiply them, but that's not what's going on here. This says add or subtract. So because it's irrational, the best thing for you to do is just kind of leave it just like this. Now, some people will try to write it like this. X equals plus or minus the square root of 6, and then they'll put plus 5, which technically isn't wrong, but we prefer integers, nice numbers, before irrationals. So when we write this, the proper notation says put the nice number first, and the irrational number, the not nice number, put it last. And that's kind of, I know, degrading to our irrational numbers, but it's the proper way to write them. So I would like to encourage you, that's how you're going to see it on the ACT, that's how you're going to see it in other classes. Try to write the integer, the number that is the whole number, whether it's positive or negative. Try to write that first. All right, let's look at number 8. We're going to subtract 10. We've got x plus 6 squared equals negative 10. I've got the square root of both sides. Oh no, I've got the square root of a negative. Do you remember what to write? No. Real solution. With an exclamation mark, because we're excited. We got that. I like those because less work. Also, I like the one on the left also because less work. I don't have to take the time to add and subtract because I can't. All right, you want to try 9 and 10? See what you can do. Pause the videos. See if you can figure them out. All right, number 9. We're going to add 18 to both sides. 7 parentheses squared equals 28. I cannot distribute that 7, so I'm going to divide both sides by 7. I'm going to have x minus 4 squared equals 4. Ooh, that's a nice number to take the square root of. What's the square root of 4? Do you remember? Did you say plus or minus 2? Because that's the answer. All right, we're going to add 4 to both sides. Now, this is one you can add 4 and 2. So we're going to come over here. X equals 4. Remember, the plus or minus 2 is on the 2. So we're looking at 4 plus 2 and 4 minus 2. So 4 plus 2 is 6. So x is 6. 4 minus 2 is 2. Those are your 2 answers. X equals 6. X equals 2. All right, let's look at number 10. We're going to subtract 101. I'm going to break out my calculator because right off the top of my head, I am not completely sure about that. 20 minus 101, negative 81. But don't go crazy because look, there's a negative number we're about to divide by. So it's going to be okay because we'll get a positive in just a second. Now, minus 1, x minus 1. All right, so x minus 1 squared equals, now a negative divided by negative is a positive. 81 over 4 doesn't reduce. We have a fraction, but we're going to be okay because watch this. We're going to take the square root of both sides. Remember I taught you square root at the top over the square root at the bottom? This was for that moment. So x minus 1 equals plus or minus, the square root of 81 is 9, over the square root of 4 is 2. We need to add 1 to both sides. So I'm looking at x equals 1 plus 9 halves, and x equals 1 minus 9 halves. Remember the plus or minus is on the 9 halves. I like to get rid of the 1 for a moment and change it to a 2 over 2. 2 divided by 2 is 1. You okay with that? Because then I have a common denominator. So 2 plus 9 is 11. So 11 halves is one of my answers. 2 minus 9 is negative 7. Negative 7 halves is my other answer. So we're solving equations by taking square roots. All right, so what do you think about this mean? What are the answers? 1 and negative 1. There is another. There are 2. And the only one that you really have to watch out for is what happens when you take the square root of a negative. All right, guys, that's the video. I'll see you in the next video. Bye.